name is Fateh Nur Al-Khalil Aimuli binti Abdul Alif, and today I'm going to present to you about my thesis report entitled Optimization of the Process Parameters for Friction Stir Welding in Marine-Grade Aluminum Alloy by Stainless Steel Tool Pin with Analysis of Design of Experiment D.O.E. This is my title and the figure showing the milling machine that I've been using. Chapter 1, Chapter 2, Chapter 3 will be introduced initially. In Chapter 1, we have problem statement, research objective, and scope of research. First is the problem statement. The aim of this research is to investigate the highest tensile strength produced with a determined parameters of transverse speed and rotational speed on aluminum alloy 6061. And based on the current situation, the issue the industry facing is for the surface finishing of the aluminum alloy. So by doing this research, I want to determine whether by this parameter can solve the smoother surface that have been encountered by the industry. And not only that, they also encounter that the certain parameters are not suitable for the combination welded region, and it causes in errors during the process. So that is why the parameter between 500 and 660 is selected to be experimented whether it is suitable for friction stir welding aluminum AA6061. Based on the problem statement, there are three objectives. First one is to determine the tensile strength of welded part region by two process factors. First one is rotational speed and transverse speed. Rotational speed, we have 500 RPMs and 660 RPM, while transverse speed, we have 6 and 16 millimeter per minute. The second one is to analyze the microstructure of the highest and lowest welded part with scanning electron microscope. And the last one is by having the analysis and the result from the first two objectives, we can determine and identify the optimum parameters can be used for friction stir welding on AA6061 plate. Scope of research. This is how I've been doing initially and until the end of the process. First is to collect data on parameters by the usage of the FTK workshop or by the research itself, and then we start for our Taguchi method and analyze for two process factor of two level. This is because Taguchi method use process factor formula which is 2 to the power of n. N is the number of factors that I've been testing, and n is equal to 2, so the number of trial is 4 tests. After that is shaping AA6061 into 55 times 20 millimeter for length and welded for trials of 6061 for different parameter applied including 2 sample each. And after the welded, we will test on tensile strength and the scanning electron microscope. And after that, the result will be inserted back into the Taguchi method. And having all analysis and result, we can determine the optimum parameter. Next is Chapter 2. In Chapter 2, we'll be discussing first on the advantages of friction stir welding, why I choose to undergo friction stir welding process. First is because the friction stir welding is a unique method, not like any other welding which use electrode or extreme heat. Friction stir welding use friction force to combine two plates together, and the existence of friction stir welding is also contributing to reduce the cost of welding as it only uses the friction force as a method of combination. And not only that, it can be performed using either custom design gear or adapted current industrial equipment entities. And this I have encountered for the second advantages because supposedly we will be using the friction stir welding laboratory, but instead, due to limitation, I apply the friction force method by using milling machine, and the result is achieved. Secondly is the AA6061 aluminum alloy. The interesting part of AA6061 aluminum alloy is it is one of the material that used to design deck and hull in marine application due to its mechanical characteristic of yield stress 252.38 megapascal and elongation of 24.16%. And the ultimate tensile stress is 350 megapascal. And for the stainless tool pin, usually people will be using D2 steel, but instead of using the same and commonly D2 steel, I choose another higher strength than the aluminum, which is tensile steel tool pin. And it is, of course, due to tensile steel is largely made of iron and carbon, with the addition of several additional alloying elements. And it is also said that for the tool pin, we must select a material which is higher tensile strength than the aluminum plate of AA6061. And that is why I choose stainless steel tool pin, because stainless steel tool pin is based on here. Tensile strength is 485 megapascal, while aluminum AA6061 is only 290 megapascal. Chapter 3. So this is the research flowchart overall. We'll be starting with the project planning and then the design experiment, welding process. After having those both result, we will data interpret and end. This is for Taguchi flowchart. The parameter setup, create Taguchi design, input value, experiment, and after having the tensile test value, analyze the Taguchi design again, and we get the result. And for the friction stir welding, first we have to laser cut section of aluminum, and secondly, making tool pin by using turning process. The depth is 2.7. You can use between 2.7 until 2.8. And the friction stir welding process, and later we will be preparing it for tensile test and microstructure sample. And here is the stainless steel tool pin that I've been using throughout the process. The height of it is between 2.7 and 2.8 millimeter. 2.8 millimeter is the maximum due to the limitation of the thickness aluminum AA6061. If I use 5 millimeter, then the maximum will be 4.8. However, I've been using 3 millimeter as the thickness, so the maximum height of the tool pin is 2.8 millimeter. And here is the process parameter measure. We have 500, 660 RPM, 6 and 16 millimeter per minute. Chapter 4 and Chapter 5. For the tensile strength is to the first one, tensile strength, is based on the first objective. We want to determine the tensile strength, and it had been run. The result showing the tensile strength and the maximum force. And the highest shows that 500 RPM with 60 millimeter per minute is the highest for tensile strength with the value of 24.067 megapascal, and also the highest in maximum force, which is 1.44 kilonewton. And here is the ultimate tensile strength UTS. As you can see, the highest goes to 500 and the lowest goes to 660, 4.4285, while the maximum force goes to 1.44 kilonewton. And here is a better view for the comparison, tensile strength and maximum force. Okay, this is one of the Taguchi method analysis. I'm going to explain to the force because it's all the same. Maximum force mean floating. It is set to, as you can see in here, the response table for signal to noise ratio. I set it to be larger is better due to the fact that a higher tensile strength means a stronger combination in the welded region. So that is why the main effect plots for means for rotational speed, tensile test, and for the maximum force is plotted as such. So it indicates that 500 is the highest, with 60 millimeter per minute is the highest. And another one to strengthen why 500 RPM is selected is due to the force versus stroke graph. Force versus stroke graph is actually the data that received during the tensile strength process. And sample 1, sample 2, sample 5, and sample 6 is arranged accordingly. So sample 2 is 500 RPM with 60 millimeter per minute, has the furthest stroke larger than 0.6, and it is larger from sample 6. And that is why 500 RPM and 60 millimeter per minute is chosen. For scanning electron microscope, we have to, because we are like identifying for the highest and lowest parameters. So for the lowest is 500 RPM and 6 millimeter per minute, A and B. As you can see, A is 10 nanometer, while B is 100 nanometer. And you can, if you differentiate between the highest and lowest, you can see numerous of grain size in the highest one, while there are only few in the lowest. And not only that, the highest one shows the worst due to existence of several holes. You can see a little like dot over there is a hole, mean that the combination of the welded is not perfectly combined. Chapter 5. So the conclusion is, by having all of the tensile strength and scanning electron microscope, we can conclude that the highest value of tensile strength achieved is 24.067 megapascal with 1.44 kilonewton. And it can be concluded that the range of the optimum parameter is 500 RPM rotational speed with 60 millimeter per minute turn speed. And the recommendation is for a better and accurate result in the future is, first, you can use different pin to apply, which you can use cylindrical, tapered, or threaded tool pin. Is the shape of the tool pin itself. And secondly, use the measurement of the parameter within a small range. It means like I'll be using 500 RPM and 660 RPM. Maybe in the future, it can be used like 500 RPM, 600 RPM, 700 RPM, or in another smaller range like 1000 until 900, and you can like 910 RPM, 920 RPM, and as such. And next is the prepare numerous material plates, more than 40 plates. Even though you are doing like only 4 trials, 8 trials, and it's a little amount, but I will always suggest that you use numerous material plates, because there are lots of problems will be encountered during the process. And lastly, aware on the laboratory limitation, because in FTKMP, the friction stir welding machine in the laboratory cannot be used due to the limitation, and it is only for student observation and demonstration. So the application of the friction stir welding is into the milling machine. And that is why we have to aware on the laboratory limitation, so we can have another from plane A to plane B. And this is how the tool pin is making. This is called the turning process. And here is the first cell clamp jig. Okay, for the first cell clamp jig, the result is not the one that I expected due to this. I can't show you. It's because the tool pin go through into the aluminum AA6061, which means there's a problem with the clamp jig, because I tested it for more than 10 plates. So we used the original one from the laboratory, and you can see the differences on the welded region here is much smoother than this one. And here is the milling machine that I've been using throughout the process. And here is the not the actual parameter, because I tested with several parameters as well before starting. to know how it will work and what will happen during the process. And you can see the excessive splash during it. And that is all for me. Thank you.